So the solar panel has specifications. Like before the specification, we have different types of solar panels. We have polycrystalline, we have monocrystalline, we have amorphous, we even have the one they call transparent solar panel. So they are different. So in that solar panel, we have what we call specifications. That is where you will see the maximum power voltage, the maximum power current, which is IMP and VMP. And then we also have the one that I call VOC, which is the open circuit voltage. So this is the specification of a solar panel. So now this solar panels generates the energy that it takes up the sun energy and converts it into electric energy. Now, for the sake of professionalism, it is unprofessional for an installer to connect your solar panel directly to your battery. It is unprofessional. Rather, the solar panel is connected to the charge controller, to this charge controller, and this is solar charge controller SCC. So this charge controller has its reference voltages. It has 12 volts, it has 24, it has 36 and 48. Now we have two different types of charge controller. We have the port width modulation, which is PWM. We have MPPT, which is maximum power point tracking, which is MPPT. So the MPPT is said to perform more better than PWM. I'm going to tell you why because of this training. So now, moving on to that, we have our charge controller panel connected to our charge controller. Now, what is the work of this charge controller? It synchronizes the energy that is generated from, because they have their reference voltage. Let's assume this solar panel is rated to be 50 volts, or let's assume this voltage is within maybe 12 to 50 volts. And now this charge controller is taking it. Now, the charge controller takes up the voltage and synchronizes it. Now, between 12 to 50, we have 12, 24, 46 to 48, 36 to 48 volts. So it synchronizes the system and harness the energy. Now, we have another one, which is the battery. Now, what does this battery, let's assume this is our battery. We can have a battery bank like up to 24 volts, but this is at random. At default, this is 12-volt battery. So the work of this solar panel is to choose, specifically synchronize the energy that will be suitable to charge this battery, which is 12 volts. Choose the energy instead that will be suitable to charge this battery, which is this 12 volts. Let's assume we will have 24 volts battery bank, which is our two battery connected in series to give us 24 volts. Automatically, the charge controller will now read this to be 24 instead of 12. So that is work of this charge controller. So because it cannot, since this solar system cannot be connected directly to the battery, the work of this is to choose a suitable current that can be able to charge this battery. But have it at back mind that the energy generated from solar panel is DC, which is direct current. The energy stored into this battery is equal to DC. The energy generated from the solar panel to the charge controller DC, the one that goes to the battery DC, which is direct current. Now, we have another component, which is the inverter. Now, this inverter has a DC and it also has an AC input. Now, looking onto that, we still have our DC going on to this inverter. Now, what is the work of inverter? What the work of inverter, it is not the last, it's not the least. The work of this inverter is to convert all this energy being generated from sun into an alternating current, which is AC. Because most of our conventional appliances are AC appliances. The one we use at home, our TV, televisions are rated in AC. So you hardly see appliances that is in DC. Though recently, technology has made it so easy that you can go and see, you can easily see AC appliances, but it's majorly, and see DC appliances, majorly AC appliances you will see in the market. Or it's rare to see a DC appliances in the market. So now, since we have AC is which our conventional appliances, the work of this inverter is to convert this energy being generated from this battery into an AC, convert this into an AC so that it will be suitable for our conventional appliance, which is our bulb lighting points, which is AC, which is AC. So this now how the system works. From the beginning, we had our solar panel being installed, which takes energy from the sun, convert it to electric energy, take it down to SCC, which is the charge controller that do the synchronizations of the voltage of your battery bank. Now, the work of this battery is to store this energy, because during the daytime, there will be sun. The solar system will be working while the battery will be charged. But at night, there won't be enough energy to use at night, because there won't be any more sun. There won't be sun at night. So the work of this battery is to use the energy being stored. This battery is like a reservoir. So it's stored energy during the daytime for you to use for your conventional appliances at night. So that is work of this battery. So now we have what we call our breaker here, DC breaker. We have our DC breaker. We also have our DC breaker here. Now here we now have our AC, which is an alternating current. That is AC. Now, this inverter also has a DC. You can also connect your DC for those of you that have the DC appliances. You can also connect your DC appliances from your charge controller. It works. So, if this video is educating, if you find it very interesting, do like, share, and comment. And in the next video, we're going to be teaching you practical. This is just an illustration and introduction of what solar system looks like and the functions of the solar system. So in the course of this video, we're going to be teaching you, the next video, we're going to be teaching you how to do the installations, how to do your load balancing, how to size your solar panels. So thank you and remain blessed.